Have you ever noticed that most drones have four propellers? Why not just one, two, or even three? Well, today we're going to uncover the secret behind this design choice. Drones are making a huge impact across industries today, from filmmaking and agriculture to delivery and defense. But all of these applications depend on one critical foundation. Drones must fly with stability, precision, and reliability. So let's break it down. The way a drone generates lift is basically the same as a helicopter. Each propeller blade is slightly twisted, thicker at the front and thinner at the back. When the motor spins the blades at the right angle, air moves faster over the top and slower underneath. According to Bernoulli's principle, this difference in pressure creates lift, pushing the drone upward. In the early days, engineers actually tried making drones with just a single main rotor, like a helicopter. Fewer propellers would mean less energy consumption and longer flight times, but there was a big problem. A single rotor produces massive torque, causing the whole drone body to spin uncontrollably in the opposite direction. Helicopters solve this by adding a tail rotor to counteract that torque. But for small drones, that adds too much mechanical complexity and wastes extra power, going against the core idea of drones being simple and efficient. That said, single-rotor drones do exist. The US military, for example, once used the Black Hornet micro-drone, each costing around $190,000. Next came dual-rotor drone designs. By spinning two propellers in opposite directions, they can cancel out torque without a tail rotor. Sounds good, right? But here's the catch. Controlling high-speed maneuvers and sharp turns with just two propellers requires extremely precise control systems. As a result, dual-rotor drones still fall short in stability. What about three propellers? That's even worse. Balancing the forces becomes very tricky. Lift isn't evenly distributed, and the flight control algorithms become way more complex. It also demands higher performance motors and sensors, making it impractical for most uses. And that brings us to the champion, the quadcopter. The four-propeller design hits the sweet spot between performance, control difficulty, structural simplicity, and cost. Here's how it works. On a quadcopter, two diagonal propellers spin clockwise, and the other two spin counterclockwise. This cancels out opposing torque, keeping the drone stable. And controlling it is surprisingly simple. Just by adjusting the speed of the four motors, the drone can perform every maneuver. To hover, all four propellers spin at the same speed, producing lift equal to the drone's weight. To ascend, all four spin faster, creating more lift than weight. To descend, all four slow down. To move forward, the rear propellers spin faster than the front, tilting the drone forward. To move sideways, increase speed on one side, while slowing the other. To rotate in place, speed up the clockwise props and slow down the counterclockwise ones, creating rotational torque. The real magic, though, is in the flight controller, the drone's brain. It's constantly processing data from sensors and instantly adjusts motor speeds to keep the drone balanced and responsive. On top of that, drones also rely on GPS for navigation, communication systems to stay linked with the pilot, and cameras or other payloads depending on the mission, whether it's capturing stunning aerial shots, scanning farmland, or assisting in search and rescue. So while a drone may look simple from the outside, it's actually a finely tuned piece of engineering. And here's something worth noting. US companies are pushing drone technology forward, but globally, drone innovation, especially in places like China, continues to lead the way. Subscribe to us for more amazing analysis.